Okay, hold on to your hats, everybody. Here comes big problem number 4. This is our second video of the day. I know we have a lot today. This is probably one of the most intense parts of the year for pre-calculus. So here we go. Write down this polynomial. We have a 5th degree polynomial. It's quintic. So the number of roots is 5. And then for the real non-real table, we need each row to add up to 5, so it's possible that we have 5 real and 0 non-real roots. And because non-real roots have to come in pairs, the other possibilities would be 2 non-real, so that would mean 3 real, or 4 non-real, and that would be 1 real. So since we have 3 rows there, we're going to make 3 general sketches. And because we have a positive leading coefficient, positive 2, our lines are going to look like, or our curves are going to look like they have a line with a positive slope. Okay, so the end behavior will be like a line with a positive slope where it's going up, 1, 2, 3, 4, 5, 1, 2, 3, 1. Okay, now for the APRR list. So for the numerators, we have all of the factors of 80. So plus or minus 1, 2, 4, let's see, it's 1 times 80, it's 2 times 40, it's 4 times 20, it's 5 times 16, 8 times 10. Okay, so I think those are all the numerators. And then for the denominator, we have the factors of 2, so plus or minus 1 and 2. And so for the APRR list, we're going to have all of those numerators over 1. And then all of those numerators over 2. So 1/2, 2 over 2 is not new, 4 over 2 is not new, 5 over 2 is, 8 over 2, no, 10 over 2, everything else is even, so that's it. Okay. So now let's go ahead and do that synthetic division chart. Let's see if I can make my window a little bit more helpful. Okay. So we have 2, negative 15, 12, 107, negative 152, and negative 80. So go ahead and find some rows, and remember, even if you have a number missing, like even though we don't have 3 in the APRR list, I would encourage you to do a row for 3 anyway, because it's going to help you look for sign changes, and chances are this problem is going to be a little bit more difficult than the last one. So I'm going to pause and go ahead and fill in some rows in this chart. Okay, so here's what I have so far. So let's take a look. We have a 0 here at 4, so we know that 4 is a root, so that's good. And then we have a sign change here between 0 and negative 1, so we know there's a root in there. And we have a sign change here between negative 2 and negative 3, so we know there's a root in there. But this problem has 5 roots. Oh, here's another sign change, I didn't see that. This problem has 5 roots, and so far we know about 4 of them, and so that could be a little bit discouraging. So I'm going to give you one more piece of information that I hadn't added on yet, and that is when you see a 0 like we do at 4, take it one more row because there might be an extra piece of information that we are about to see. So here's the next row. I'm just going to quickly fill it in. Okay, there's an extra piece of information here. If you see that it goes from positive to 0 to positive, let's think about what that means graphically. If you have a point with a positive y value, and then a point with a y value of 0, and then a point with a positive y value, what is happening with the graph? Either it's going down and just touching and going back up, or it's going down through something else and coming back up through that 0, or it's going down through the 0 and coming back up somewhere else. So if it comes up, if it goes down through another point or comes back up through another point, well, there you have your other root. Somewhere between, in this case, it would be between 3 and 5. That's where those positives were. This was 4. So it could be that you have another root between 3 and 5. And if it comes down and just touches and then goes right back up, that's what we call a double root. So we would have x equals 4 and then x equals 4 again. So anytime you see positive 0, positive, or similarly negative 0, negative, then it's going to be either an extra root somewhere between, or it's going to be a double root. So the next thing I'm going to do is check to see if it's a double root. And the way I check to see if it's a double root is by dividing the number 4 into its own row. So we already know that 4 went into the problem once. Is there a chance that 4 goes in again? So let me see if I can get some more space. Okay, so I'm dividing 4 into its own row. So just down here off to the side, here's the 4, and here are the numbers from the 4 row. 2, -7, -16, 43, and 20. Bring down the first number, multiply by 4, write it down and add, multiply by 4, write it down and add, multiply by 4, write it down and add, multiply by 4, write it down and add. See how we get a 0 there? That means 4 goes into it again, meaning we have a double root at 4. So now what do we know? We know we have a root at 4. We know we have another root at 4. So if we're keeping track of our roots, we have 2 of them, and we have 3 more to find. So remember those sign changes? Let's go back to a sign change and try a fraction. So the fractions you could try, remember the options were, we had positive or negative 1/2, and we had positive or negative 5/2. So I'm not saying you're always going to find it on the first try, but just for the sake of time, I'm going to show you the one that works. I'm going to do negative 5/2, and wherever you can squeeze it in, I'll put it down here. So negative 5/2, bring down the 2, multiply and then add the next number, you get negative 20, multiply and add the next number, you get 62, multiply and add the next number, negative 48, and the next number is negative 32, and then 0. Okay. So now we can add that to our list of roots. Now we have 3 roots, there are only 2 more to find. And so hopefully we can speed this up and use the quadratic formula to find the remaining 2 roots. And here's how we do that. We already took 4, and the 4 row represented a quartic or a 4th degree polynomial. When we divided something into that, we got a cubic or 3rd degree polynomial. So let's divide negative 5/2 into that cubic polynomial, and that will give us a quadratic. I like to call it whittling it down. So you just take what you have left, divide your other root into it, take what you have left, divide another one of your roots into it, until you get it all the way down to a quadratic. So this is going to work out. I'm just doing synthetic division on this one. And this is going to work out. And what we need from that are these numbers, 2x squared minus 4x minus 2. So we're going to set that equal to 0. And let's use the quadratic formula. We can divide the whole thing by 2 first of all. If it was factorable, we could do that, but it's not. So we use the quadratic formula. And I'm just going to skip over the steps because it's a long video, but you know how to do the quadratic formula. You're going to get 1 plus or minus square root 2. Now the approximate values of those numbers would be about 2.4 and about negative 0.4. So it's time to graph. Okay, so let's look at the y-coordinates, the remainders from our table, our chart, and we have numbers in the hundreds here. We have numbers like 210, negative 126, we have 150, we have negative 686. So what if for a scale we do something like, maybe this is 100. Okay. So we're going to plot these points. We have our roots. I should add to the list. We have x equals 1 plus or minus square root 2. Now the list is complete. Okay, so let's go ahead and plot 5 to 10, 4, 0. And remember, that's going to be a double root, so it's going to go and just touch and then go right back. It's not going to go through, it's going to go right back. 3, 22, 2, negative 36. We have our root 1 plus square root 2, which is about 2.4, and negative 0.4, and negative 2.5. Oops, it's over here. Okay, and then back to the chart, we have 1, negative 126. We have 0, negative 80. We have negative 1, 150. We have negative 2, 250 something. We have negative 3, negative 600 and something. That's way down there. So let's see if this will look like the shape we were expecting. And at 4, where there's a double root, just touch and go back. So remember the shape that we thought we were going to see, that we drew back here when we drew our general sketches. Okay, so that looks good. Awesome. I know this was a lot today, and you'll probably have a lot of questions, and this is the kind of thing that we just need to practice a bunch and ask a lot of questions, and little by little you're going to get the hang of it. So here are the 2 problems that I want you to try tonight, and we'll see how it goes. Thanks, everybody.